Day 295 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem. This time we're at day 295 and we're still going strong, y'all. Today we have question number 16, three-sum closest. The difficulty level is medium, but don't worry because we're going to keep the solution as simple and easy to understand as possible, y'all. But before we get started, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description. Now let's see what the question says. Question says, given an integer array nums of length n and an integer target, find three integers and nums such that the sum is closest to target. Return the sum of the three integers. You may assume that each input would have exactly one solution, y'all. So it sounds simple enough. If y'all have done the three-sum or two-sum problem before, you should be familiar with what we're doing here. However, this time we want to find the sum that is closest to the target, y'all. So in order to do that, let's go ahead and look at example ones to make sure we're doing it correctly and we're doing exactly what it is that they want us to do. So in example one, we have the input nums equals an array of integers, -1, 2, 1, and -4. The target is 1. The output is 2. Explanation says the sum that is closest to the target is 2, which is, we get to that sum by doing -1 plus 2 plus 1, and that gives us 2. So what we're trying to do is we're trying to create a sum with these integers that can get us as close to target as possible. It doesn't have to be exactly the target. We just want to get as close to target as possible. So in this case, when we add these three elements together right here, we will get a sum of 2, and that's the closest sum that we'll be able to get possible to 1, right? So -1 plus 2 will give us 1, and then we add one more, and that'll give us a that'll give us a sum of 2, and that's close to target. Now remember, we have to use at least, or not at least, we have to use exactly 3 elements. We can't just use 2 elements and get to the target, right? We can't just say -1 plus 2 and that'll get us to the target, which is 1. But we have to use 3 elements, and whichever 3 elements we use has to get us as close to the target as possible. In this case, that is, the sum would be 2 of those 3 elements. Now, let's look at example 2 where it might be a little more tricky, right? So in example 2, we have the input nums equals an array of integers 0, 0, 0. The target is 1. There is no way, or we only have 3 integers, right? So that's as close as we can get. We have to add those 3 integers together. Luckily, in this case, those 3 integers are 0, so we just have to do 0, 0, 0, which is 0. So in that case, the sum would be 0. Now remember, we're returning the sum. We're not returning the integers themselves. Like in this case, that might be confusing, but in example 1, remember, we're not returning the integers that we're using to get the sum. We're just returning the sum of those integers. So now that we understand the question, y'all, let's get into the fun part, the actual solution. You know we're going to keep the solution as simple and easy to understand, so let's get into it. Now, the first thing we need to do is we need to sort the input array, which will enable us to use a two-pointer approach. So in order to do that, all we have to do is we can say let sorted equal nums dot sorted. Then put the parentheses at the end. Then we're going to say let length equal sorted dot count. Boom, just like that. Now we need to initialize some variables to track the minimum difference and the closest sum. So in order to solve this problem, right, we're gonna find the sums of as many integers as we can or as we need to until we find a sum that when we find the sum, then we're going to find the difference of those sums from 1, right? And whichever has the smallest difference, that means we are the closest to the target. So we need to find the sum of different combinations of these elements, right? And then when we find those sums, we just find the difference between those sums and 1. And once again, whichever has the smallest difference, then we'll know that's the closest. So to initialize those variables to track the difference, we are going to say, we could just declare a variable, and we could call that diff, short for difference, and we'll say colon, set that is, or cast that as an integer, and set that equal to dot max, just to start. Then we are going to declare another variable, call that result, set that equal to 0, and now it's time to get started with our for loop, right? So now we need to iterate through each number in the array, treating it as the first element of the triplet. So in order to do that, we're just going to say for I in 0 dot dot less than sign length, so up to length, then we're going to say -2, boom, we're going to open up the brackets. Now we need to create our variables for our 2-pointer approach. So in order to do that, we could just declare a variable, we could call it n and set it equal to I, then we'll say comma, and then we'll just say q and set q equal to length -1. Boom. Now we need to continue until the 2 pointers meet. So to do that, we could use a while loop, and we can say while n is less than q. We'll open up the brackets. Now we need to compute the sum of the triplet. So in order to do that, we could just say let sum equal sorted square bracket I plus sorted square bracket n plus sorted square bracket q. Boom. Now we need to adjust the pointers based on the comparison with the target. So in order to do that, we could just say sum is greater than target. This right here is going to return a Boolean for us, so either true or false. So if that is true, open up the parentheses. If that is true, we'll say parentheses q minus equals 1. Then we'll come right here and say colon. For if it's false, we'll say open up the parentheses. We'll say n plus equals 1. So if this comes back true, we'll return this. If it comes back false, we'll return this. That's what this question mark and colon are helping us do. So now we need to calculate the absolute difference, just in case we have dealing with negatives. We want the absolute difference, meaning it'll just convert a negative to a positive, because we just want to know how far away is it from 0. So in order to do that, we could just say let value equal ABS, open up the parentheses, sum minus target, just like that. Now it's time to update the closest sum if a smaller difference is found. So in order to do that, we could just say if value is less than diff, open up the brackets, we can say diff equals value. Then we come right here and we can say result equals sum, just like that. And now we need to return the sum that is closest to the target. So in order to do that, we can just come right here, and all we have to do is say return result. Now that should be all she wrote, y'all. Let's run it. Let's run it, make sure it runs like it's supposed to. Ooh, we got an error, so what does it say? Let's see. Oh, excuse me, y'all. This shouldn't be a equal sign. This should be a minus sign. Sorry about that. So let's go ahead and run it again. See what happens. Ooh, we got the wrong answer. So one thing to keep in mind when you get the wrong answer is probably something wrong with the math. And right here, this should be n equals I plus 1. Sorry about that, y'all. But yeah, those wrong answers could get tricky because it doesn't tell you where the error is. But most of the time, that just means there's something wrong with the math. And look at that, y'all. It's accepted. So let's just go ahead and submit it. Make sure it stays accepted after we submit it to make sure everything is still running properly. And look at that, y'all. 11 milliseconds beats 46.86% of users with Swift. Those numbers are all right, but we're not really focused on the numbers right now. Right now, we're focused on being able to solve the problem that is presented to us. And and understanding the solution that we use. I feel like this is a good solution to understand, and it's a solution that we will be able to learn from and apply the knowledge that we learned on future solutions, right, to make us better leak coders as we continue down our leak code journey. So before we go, y'all, get one more look at the code. One more look at the code. That's the top half. Boom, that's the top half, y'all. Now see y'all here tomorrow for another day, another leak code problem where we're doing daily leak code problems. I'll see y'all then.